Hi everyone, welcome to a new video. In this video I'll be sharing with you guys another IBM coding question. In the last video I have discussed one coding question and I hope that video was helpful for you. So in this video I'll cover another one. If you have any question, any doubts, you can let me know in the comment section. So any further delay, let's get started. So this is the question is given to us. Consider an array of integers and a non-zero positive starting value x. A running sum is calculated by adding each element of the array to x consecutively. Determine the minimum value of x such that running sum is at least 1 after every iteration. Okay, so this is the question. So first you have an integer array. Now you have to calculate the running sum of that particular array. Okay, but while calculating your running sum, you have to make sure that in each running sum that value is at least 1. Means the summation value at least 1. Okay, but while calculating your running sum, you have to take the element of the array to x consecutively. Means you have to start your running sum calculation with a starting value x. Okay, and this x can be anything, any positive number, but in this coding problem you have to find out the minimum value. Okay, from that you can start your calculation. Okay, because in the question also it is saying like determine the minimum value of x. Okay, so you have to find out the minimum value of x, right? It can be anything, any number it is possible, but you have to find out the minimum one. Okay, so now you have to start your calculation with this particular x value, and that x value you have to determine the minimum one. Okay, now you can start your calculation, and you have to make sure that in each summation or like each sum, the summation value should be at least 1, means greater than or equals to 1. Okay, I think this question is little much clear to you. If it is not, then that is totally fine. If you see the examples, then definitely you will get it better. So now let's go to the examples. Okay, so this is our first example. Okay, this is the array is given to you. Okay, suppose this is our x value. Okay, although this x value you have to determine, means you have to calculate this x value, but suppose for now this x value is already given to us. Okay, so now you have to start your running sum calculation with this given x value. Okay, so 5 plus minus 4. What is the minus 4? Minus 4 is coming from our array. It is our first element, means 0th index position element. Okay, whatever value we are getting from our first summation, that is 1. Okay, 1 plus 3. 3 is our second element, means 1th index position element. Whatever value we are getting, means like here we are getting 4, then this summation result we will use in our next summation. Okay, now we will add 4 plus next element of our array. Okay, that is 2, and now our summation is 6, and 6 plus 1, 1 is our last element of our array, and 6 is our last summation value. Now our result is 7. Okay, so now suppose if you take x equals to 4, then you can see 4 plus minus 4 is 0, right? Is 0. But in our question it is saying to us like running sum is at least 1 after every iteration. So you cannot take 4 or 3 or 2 or 1, right? You have to start with 5, and this 5 is the minimum value. From that you can start your running sum calculation. I think this question is totally clear to you. If it is not, then that is totally fine again, because when we will do the coding, then you will get it better. Okay, so now let's see the second example. Okay, this is the array is given to us, and now if its starting value is 4. Okay, suppose this x value is given to us. Okay, so now if your running sums are 7, 1, 6, 4, 5. Okay, so like 4 you have, so 4 plus 3 is 7, right? 4 plus 3 is 7. Okay, and now this sum value is 7. 7 minus 6 is 1. Okay, and in each iteration you have to make sure that you are running some value is greater than or equals to 1. Okay, so you cannot take, like here instead of 4 you cannot take less than or equals, means you cannot take less than 4 value, right? Because if you are taking less than 4, like suppose if you are taking 3, then 3 plus 3 is 6, right? And 6 minus 6 is 0. Then you are running some condition will get failed, so you cannot take 3. Okay, so you have to start with 4, right? I think this is clear. So now it is like 1, then 1 plus 5 is 6, right? And 6 minus 2, what is the value? 6 minus 2 is 4. Yeah, 4. 6 minus 2 is 4. 4 plus 1 is 5. Okay, now our starting value is 4. Okay, so for this example our x value is 4. Okay, right? So now the third example actually. So here this is the array is given to us. Now our starting value x is 1, because the summation can be anything, but you have to make sure that whatever value you are taking for x, that is should be a positive value, right? So you cannot take 0, right? So you have to start with 1. So this is the least value that you can take for x. Okay, if you are little confused, then you can see here also, like you have to take a non zero positive starting value. Okay, so non-zero positive you have to take. So that's why for the last example you can see the same, like suppose this is the array is given to us and this is our x value is 1, because you cannot take less than 1, right? Because you have to take non-zero positive value. So this is the one thing, this is the one way that you can take the least value you can take, right? Because you have to make sure that your x value is minimum 1, right? So now if this question and these examples are not clear to you properly, that is totally fine. Now we will see the solution, then that would definitely help you to understand this question and examples better. Okay, so before going to the solution, I just wanted to show you the method, the how we will solve this question. Okay, this is the array is given to us, right? So let me first describe you like how we will gonna solve this problem. Okay, so this is the array, right? So we will take two variables. Okay, first one is the current sum, okay, and the second one is the minimum sum. Okay, minimum sum will start with 0 and also current sum will start with 0. Okay, so this is our first element. Okay, so what we'll do, we'll do current sum equals to current sum plus ARR of 0th index position element. Okay, that is minus 4, right? So now our current sum is minus 4. So in minimum sum we are storing the minimum sum of current sum and minimum. Okay, so what is the minimum of 0 and minus 4? That is minus 4, right? Because we have to store in minimum sum, we have to store the minimum value. Okay, so that's why we are storing minus 4, right? This is about our first iteration. So in the second iteration we have our 3. Okay, so in the current sum now we what we will have, minus 4, right? Minus 4 plus 3. Okay, so now our current sum is minus 1. And what about the minimum sum? We have to store the minimum value. What is the minimum of minus 1 and minus 4? Minimum value is minus 4. Okay, so now let's go to our third iteration. Okay, so in the third iteration we have 2. Okay, and what is the current sum? Minus 1 plus 2. Okay, and now it is 1. And now in the minimum sum you have to store the minimum value. Okay, and what is the minimum of minus 4 and 1? Obviously minus 4. Okay, so now let's see our last iteration. Okay, so in the last iteration we have our current sum, whatever value we have, last means the last current sum we had 1. So now 1 plus our last element is 1. So our current sum is 2, but our minimum is still -4. Okay, so now at the end what we will do? We will do 1 minus 4. Okay, so now what we will get? 5. Now you can check your x value as well. Okay, yeah, it is matching with our x value. Right, the point is why we are doing 1 minus, because if you can remember in the question it was saying like in that is the running sum is at least 1 after every iteration, right? So that's why we are doing at the end we are doing 1 minus. Okay, and -4 why we are taking? Because you have to calculate the minimum running sum. Okay, and this is the minimum running sum we have. Okay, and now what we are doing? 1 minus, because in each iteration you have to make sure that that value is greater than or equals to 1. Okay, then 1 minus -4 is 5. Now let's start the value with x equals to 5, and that 5 now you are getting from this. Okay, so same way you can do the here as well. The whatever calculation we did in for this example, you can do the same for this example as well, and then you can see you will get the same result. Okay, so I think this concept is little clear to you, like how you will gonna solve this question. So now let's see the code. Okay, so I will write down the code in Java, but you can understand the logic and then you can write down the code in any language. That should not be any problem. So now let's go to our Eclipse. Okay, now we come to our Eclipse, right? This is our scanner class. Like here we are taking our length, and now we are taking our values in our array. Okay, so whatever value we are taking, we are just storing the values in our array. So this is the function that we will use for calculating the minimum k value. Okay, or like minimum starting value, right? So now as we have discussed that we will use two variables, right? One is minimum like sum, and another one is the current sum. Okay, so now let's do the same. As we have to return long type variable, we will take long type variables as well. Okay, so current sum equals to 0 and long minimum sum equals to 0. Okay, so now what we'll do? We'll do a simple thing. We'll do, okay, int I equals to 0, I less than arr dot length I plus plus, right? And then what we'll do? We will do current sum plus equals to arr of I, right? And then min sum equals to math dot min. Okay, not mathy, math dot min will do, and then minimum sum, and we have to find out the minimum sum between min sum and current sum. Okay, current sum, right? So now what we will do next? At the end we will just do one thing: 1 minus min sum. Okay, so yeah, this is our solution. So now just quickly run this code. Okay, the length you have to pass, it is 4, and now 1, not 1. Okay, so now our x value is 5. So now it is working totally fine. Okay, I can understand, like you may confuse like why we are even calculating this minimum sum, or like why we are doing return 1 minus, why not 2 or 3 minus. So that I will describe little bit more for your better understanding. Okay, so now let's go to our PPT again so that I can write down easily, right? So yeah, okay, so suppose I am taking, this is the second example, right? So this is the values we have. Okay, so like we have to calculate the current sum in each iteration now, and also you along with that you have to calculate the minimum sum. Okay, so we'll start the current sum is 0 and minimum sum is what? Also 0. Okay, so this is our array, right? So what is our current sum? How we are calculating current sum? Equals to current sum plus a order of I. Okay, so now our I value is 0. Okay, so now this is our first element. So current sum is 3 and minimum value, mean sum is still what? Mean value is still 0 only. Okay, let me just create one table so that it is be better for understanding. Okay, this is our first iteration. Okay, second iteration, what will be the value for current value and the minimum value? What is second iteration? Our second value is minus 6. So minus 6 minus 6 minus 6, 3 minus 6, what is the value? 3 minus 6 is minus 3, right? So our current sum is minus 3 and our minimum value is also, minimum sum is also minus 3, because in minimum sum we are calculating the minimum one we are adding, right? So now both current and minimum value is minus 3 and minus 3, right? So now our third iteration is 5. So minus 3 plus 5 is 2, right? It is 2. So now our current value is 2 and our mean value is still minus 3. Okay, fine. Next we have minus 2. So 2 minus 2 is 0. So now our current value is 0, but it is still minus 3. Okay, so let me just write 0 here also. So now last time we have 1. Okay, so 1 we are adding. So now our current value is 1. Okay, sorry for my bad handwriting because I am writing with my mouse, so that's why. So please try to understand. Okay, so our minimum sum is still minus 3. So what we have discussed, like we have to do at the end 1 minus minimum sum, right? So 1 minus f minus 3 is what? 4, right? This is 1. Okay, so if you can see, our starting value is also 4. So now why we are doing 1 minus, not 2 or 3 minus? Why so? Because if you can remember, in the question it is saying like it should be maintained, like in each running sum the value should be greater than or equals to 1. If you cannot remember, yeah, running sum is at least 1 after every iteration. Okay, that's why 1 minus, because what you have done? You have done the total sum you are calculating of this array. Now you are not taking the total maximum value, you are taking the minimum sum that we can get. Okay, from this array you are taking the minimum sum that you can achieve. Okay, minimum sum you have achieved means this is the minimum value you can get. Okay, so now you have to check like how much is it difference from 1. Like you have minus 4, right? So how much it is difference from 1? So how we can calculate? Suppose you have 100 rupees, right? So now you have the whatever you have like purchase and whatever you have like buy and all the things you have purchased, total 60 rupees. So how much it is difference from 1? From 100 minus 60 is 40. So 40 rupees is difference. That means you have saved 40 rupees, right? Same way, this is the array it's given to you. You have to find out a minimum sum. Okay, means this is the minimum value you can get. It may possibly your minimum value is only 1. Okay, only 1 it may possible. You have, although in every sum you have to maintain 1. Okay, but your total minimum sum is also 1, but still your x value is 1 only. Why so? Because if you see, like your x value should be non-positive, non-zero positive starting value, right? And so your x value should be greater than or equals to 1. So it's not like that. Like if you are getting one minimum sum that is like not a negative value like 1, 2, 3, 4 whatever, still you will have to take your x value greater than or equals to 1. Minimum 1 you have to take. Okay, so my point was that like whatever value, whatever minimum value you are taking, that you have to find out how much it is difference from 1. Why 1? Because in each iteration you have to maintain that one thing, that if each iteration your running sum should be greater than equals to 1, right? So now if whenever you are you are just calculating all the value, you are just you have just find out the total of all the numbers, not the total sum you are taking. What value you are taking? The minimum sum you can get from your array. Minimum sum you can get from your array, that you are find out, right? That you are finding out, right? So after finding out the minimum sum, then what you can do? You can just find out how much it is difference from 1, right? Then you can easily find out what is the minimum value you have to add that in each iteration to make that every step you can get 1 greater than or equals to 1, but means at least 1. Okay, I think it is little clear to you. If it is not, then that is totally fine. If you go through this video one more time, I think you can understand it. The main point is that you have to find out the minimum sum. Okay, then you have to find out the in each iteration how much value you should have, how much value you should have in your running sum. Okay, like as per this question, in each iteration, in each running sum, you should have at least 1. Okay, so whatever minimum sum we are getting, now we are calculating like how much it is difference from our minimum requirement. Here our minimum requirement is 1. Okay, so 1 minus of our minimum sum. I think this is clear to you. Okay, so now let's go to our eclipse again, right? So now this is our eclipse. So let me just take this array as well. 1 2 3 4 5. Okay, our array size is 5, right? Array size is 5, and what are the element we have? Okay, yeah, we have 4. So now this code is totally working fine. Okay, so I think this solution is clear to you. I know this is bit confusing, but actually the point is that here your time complexity is very efficient, because here we are only using time complexity is order of n. Okay, because we are only taking one for loop. Okay, and here our space complexity is order of 1. Why so? Because here we are not taking any array and all. Yeah, we are taking this array, means in this algorithm we are not taking any another like collection or like any other array, or like you can understand, right? So means here we are only taking 2 variables to solve this question. Okay, so this is the optimized way. This solution is clear to you. If it is not, then you can try this solution in your own, and then you will definitely understand it. Okay, so yeah, that's all pretty much from this video. So I hope this video is helpful for you, and thanks for watching. I see you in the next video. And if you like my videos, don't forget to subscribe to my channel and like this video. So yeah, thanks for watching. I see you in the next video. Bye bye.